Right, so in general, every quadratic function is of the form f of x equals ax squared plus bx plus c, where the highest degree of the polynomial is always going to be 2. So if I compare these two polynomials, then my a is whatever number that multiplies x squared, or the coefficient of x squared. In this case, it is just 1. B is whatever number that multiplies x, or the coefficient of x. In this case, it is negative 4. C, of course, is the constant. C here is 3. I want to look at 5 characteristics of the quadratic function, and I will use these characteristics to graph the given function. I will first want to talk about the line of symmetry. This line divides our parabola into 2 equal parts. The line of symmetry. This line of symmetry is the equation x equals negative b all over 2a. So from the given function, my b is negative 4. So negative of b is just 4. Divide 2 times a. My a here is just 1. So I have 4 divided 2. The line of symmetry is x equals 2. The second property is to speak about the vertex. In other words, called the turning point. Now this vertex has the line of symmetry as its x-coordinate. This x-coordinate is the line of symmetry. So the line of symmetry x equals 2 is the x-coordinate of the turning point. So I have 2. How do I find the corresponding y coordinate? I need to just sub 2 back into the given function. So I have 2 squared minus 4 times 2 plus 3. This is 4 minus 8 plus 3 minus 1. So my vectors is 2 and minus 1. The third and fourth is to talk about the intercept. I can speak of the x-intercept and the y-intercept. X-intercept, y equals 0. Y-intercept, x equals 0. So I will first talk of the y-intercept, where I sub x equals 0 into the original function. So I will be looking for f of 0, which is my y. And that is just 3. So the y-intercept, I have 0 and 3. I can look for the x-intercept now. Where y is 0, so that means I have 0 equals x squared minus 4x plus 3. I can easily solve this quadratic by factoring, looking at factors of 3, 1 times 3, and then using the sum and product. I can rewrite this as x minus 1, because minus 1 minus 3 makes a sum of minus 4. And minus 1 times minus 3 will give a product of 3. So I can do x minus 1 and x minus 3. If I solve each of the factors, I have x equals 1 or x equals 3 as my intercept. So the coordinate there will be 1 and 0 or 3 and 0. Knowing all these characteristics, I can easily graph my function. So it starts with the line of symmetry, x equals 2. Let me just keep my 2 here. So there is symmetry about this line. It has a vertex, turning point 2, negative 1. This is 2. So if this is negative 1, the graph should turn at this point. But anytime this value of a. Anytime a is positive, we have concave up, or the parabola opens up. If a is negative, we have concave down, or the parabola is going to open downwards. So in our case, a is just 1, positive 1. It means the parabola must open up at the turning point. Then we can look for the intercept and graph. It has y-intercept, or meet the y-axis at 0 and 3. 0 and 3 somewhere here. There is x-intercept, x equals 1, x equals 3, x equals 1 somewhere here, x equals 3 somewhere here. Then this is the nature of my graph. Goes through the y-intercept at 3, goes through x-intercept at 1, turns around the betas, and goes through the next x-intercept at 3. This is a detailed graph of a quadratic function. Don't forget to subscribe to the channel, and let's continue to make maths beautiful. Thank you.